presentation, or am I?
Oh, that was fun. I get it. You got it.
The youth in my day was not so loud. Now, you be quiet and respect your elders. Your teacher has asked me to please tell you a little bit about the discovery of radiation and my work. So I am here to talk to you about that. My name is Marie Curie. And I was born in Poland in 1867. Now, in 1891, I went to Paris because when I was in Poland, there was no opportunity for women to have a higher degree. And I was so interested in science that I wanted to study it further. Now, it was not easy for women to get a higher degree in France either. And so what I did was I was there, and I was the only woman in my classes, although I was the top of my classes. And while I was there, I met this wonderful man named Pierre, who I later married, Pierre Curie. Now, at this time, it was a very exciting time to be a scientist, as it always is. What was going on is that there was this gentleman named Röntgen, and he was using Crookes tubes. Now, you may have heard about this when you were studying about J.J. Thomson. Crookes tubes had a gas in it, and there was a cathode ray that went through it. And one of the things that Röntgen discovered was that it gave off an invisible light. And this light could go through things, and when it hit a photographic plate, it made that plate be exposed just like in the sun. And he was so excited about this, and he called these X-rays. And everybody was excited. Everybody wanted X-rays. Everybody wanted to have their body X-rayed. Everybody wanted to learn about X-rays. And you can see there is Röntgen, and that is the picture of his wife's hand with a ring on it. And this is how they used to do it. They would take the cathode ray, and it would give off the X-ray, and it would go through the woman's body, and then they could take the picture of her with that on the back. So, now my friend Henri Becquerel, he was very interested in this, and he was very interested in the photographic plates, and he would take these photographic plates, and he would cover them with some black paper, and he would let them sit out in the sun for hours to see whether or not the sunlight could go through the photographic plates. And then they would get exposed over many, many, many hours, and he would see what it looked like. Well, one day it was very cloudy, and so he put his photographic plates away. And when he developed them a couple days later, thinking they're not going to be much of an image, there was a very strong image. He could see very clearly that it had been exposed. And this was very confusing because there was no sunlight. So where did this energy come from? Well, he thought about it and thought about it. And then he thought about the fact that what is this sound? This is a very annoying sound. He said, well, in that drawer there were these rocks called pitchblende. And somehow, maybe this energy came from the rock. Like the sun was trapped in the rock. And inside the rock, there was uranium. And he thought, well, maybe the uranium was giving off this energy. So this was very exciting, but we were all very confused because if it was coming from the uranium, how did the uranium get rid of this energy? Aren't atoms indivisible? Well, at the same time that he was doing this, J.J. Thomson had determined that those cathode rays that we were all so excited about were actually streams of particles that were negative that we called electrons. And that told us that maybe the atom wasn't indivisible. Maybe things were coming out of the atom. Maybe it had made of things in it. And maybe energy could come out of it, maybe. So, but electrons were not energy, so we weren't sure. And I was very interested in this. I thought, this is what I want to study. This is what I want to know. So I decided to study pitchblende, and I read all the articles I could find on them. And one thing that was very interesting to me was that if you take a piece of pitchblende and you measure, and you see how much light and how much exposure it is able to give, it gives off much more than just uranium. So there's something else in pitchblende that was producing this invisible sunlight. This was very I was passionate about learning about this. I must know it. Now, it was very hard to do research. First of all, I was a woman, and nobody was interested in giving me money or giving me support. So I had no laboratory, I had no funding, I did not have very much support from anyone, except from my beloved Pierre. But I found an old warehouse that was drafty and had no heat, and I made that my laboratory. And it took a very, very long time to figure out what was going on. Because when I first studied pitch blende, I realized very quickly that I would need a lot of it. In fact, I needed over a ton of pitch blende. And so I had wagon loads full of rocks come in and dumped into my laboratory, and I spent 2 years crushing the rocks, breaking them apart, making them really small, and it was back-breaking work. And it was very cold in the winter, my hands almost froze. And it was very hot in the summer, and I almost passed out. And I didn't have any food because we were very, very poor, and there were days when I didn't eat at all. But I didn't care. Do you know why I didn't care? Because I was learning science. I was finding things out that nobody knew. I was discovering the secrets of the universe, and that is the most important thing I could do. I couldn't wait to find out what that invisible energy was. So there is a very bad picture of me in the laboratory. And here is my husband, Pierre, and we are measuring the radioactivity. And we had to, after we crushed all those rocks, then we had to try to separate the chemicals out of the rocks. And we would try it with acid, and we would try it with bases, and we would try different chemicals and all sorts of things to try to separate the different substances. And I would measure how radioactive certain parts were to know whether I was getting the part that I wanted. And finally, at the very end, in 1898, I found polonium. I named this element polonium. Does anybody know why I named it polonium? Yes.
Was it after Poland?
It was after my beloved Poland. Now, I loved Poland. I always wanted to go back and work there, but there was no opportunities for a woman to work in Poland. So therefore, I stayed in France, but I named it polonium. And polonium was 400 times more radioactive than uranium. Now, polonium would glow. When I had it concentrated, it would glow. And I would go into the laboratory with my husband, and we would be at night, and there would be green glowing all over the room. And it was so beautiful. It was like glowing tubes that looked like faint fairy lights. It was one of my favorite things to do, was to look at the beautiful glowing polonium. And then, a little later in that same year, I realized there was another element in there, and I discovered radium, which I named for the rays that it gave off. And the thing about radium is that it is 1,000,000 times more radioactive than uranium. And I got such a tiny amount. Out of a ton of pitch blende, all those years of back-breaking work for all of those rocks, less than 1/10 of a gram. That is it. But I got it. And in the 1940s and 50s, my radium was used to paint the hands on watches so they would glow and people could see their watch in the dark. It ended up being sort of a problem because it was not a good thing to have radioactive radium on watches, especially for the girls that would paint the radium onto the watch and make the tip of their paintbrush very, very sharp by licking it. It was not good. But we didn't know this then. Now, the problem with studying radioactive things is that when one studies strongly radioactive substances, special precautions must be taken. And that is because the dust, the air of the room, and one's own clothes all become radioactive. And in fact, your teacher was telling me that even nowadays, my notebooks are too radioactive to handle safely. So that was not good. But we did find a lot of good things from it, and some of the things that my discovery led to was that I received my doctorate, and I was the first woman in France to receive a doctorate in science. But I was denied entrance into the French Academy of Sciences, which is the highest honor in France for a scientist, and I lost it by 1 vote. And one of the scientists there said there was no place for women in the Academy of Science, and I was so angry that I refused to let my name be submitted again, and I refused to publish in their journal for 10 years, which was not very happy for them, because by then everybody wanted my publications. Also, a unit of radiation was named after Curie. Now, I won the Nobel Prize in Physics with my husband Pierre and with Henri Becquerel for our discovery of radiation. And this is an interesting story. Initially, I was not going to get that award. It was being given to my husband and to Becquerel. And my husband refused to accept it, saying that it was all my idea and my work, and he was just helping me. And Becquerel also said that this was my thing and I deserved it. And they finally decided that I should get the award as well. And then, in 1911, I won the Nobel Prize by myself in chemistry for discovering 2 new elements. I am the only person to win 2 Nobel Prizes in science, and there's only one other person who has won 2 Nobel Prizes. One, he won it for science, and the other for peace. You'll find out about that later. That's after my time. Now, there's a lot of good that my radium does, even though it can cause some damage to your body. Because radium is radioactive and it can expose photographic plates, and I was able to use it to have a moving X-ray, and I was able to bring it to World War I, and the doctors were able to use my radium and the X-rays and be able to determine where shrapnel is and be able to do surgeries to save people. We were also able to use it to help keep limbs from developing gangrene. So it ended up being a very helpful thing. And I was very passionate about the war. I very much wanted France to win, and I offered to melt down my Nobel Prize medals for the war effort, but they refused to take them. But I used all my Nobel Prize money and gave it to buy war bonds. I really didn't have any purpose for the Nobel Prizes. In fact, when I was offered it, I didn't even go and get it. I was too busy in my laboratory doing research to waste time doing Nobel Prize winning stuff. And now, in conclusion, we must not forget that when radium was discovered, no one knew that it would prove useful in hospitals. The work was one of pure science. This is a proof that the scientific work must not be considered from the point of view of direct usefulness. It must be done for itself, for the beauty of science, and then there is always the chance that a scientific discovery may become, like radium, a benefit for all of humanity. Do you have any questions about my life or my research? Yes?
When you said that, all your notebooks and your clothes and everything became radioactive, how did that work? Is it radioactive when elements decay?
Yes, no. So I was using using this pitch blende, and little atoms would fall off of the pitch blende and get on my clothes and get on my books, and then those atoms would decay and be radioactive. So there are still atoms from the polonium and the radium that are still on my notebook that are decaying and being radioactive. Yes?
Did the radioactivity do anything to your health?
Yes, sadly it did. It made me, when I was older, it made me anemic and it made me ill. And eventually I died of it, but I'm not dead yet, so I think that's a rumor.
How?
Yes. Yes?
What about your lab? Have people been able to go in?
Yes, well, my lab, let me tell you a story about my lab. I did not like that lab. It was very cold and very hot and very windy. And once I got my Nobel Prize, I wanted a new lab that the university would give me, and they said no. And so I said, that is it. I am going to a new place, and then they gave me a new lab. So that lab no longer exists. Any other questions? Yes?
What does radioactivity mean?
Radioactivity means that something that is radioactive is an element that can undergo spontaneous decay into something else. Now, I didn't quite know that yet. I did not understand at this point, when I was making these discoveries, how that energy was being created inside the atom. But later, with different experiments, we discovered that it wasn't the nucleus breaking apart and giving off energy. Yes?
Why does it harm reactive?
Okay, because what happens is that the energy that is given off hits your cells, and your cells get damaged by it. And so that can be good and it can be bad. It can be bad because you can kill your cells, or your cells can mutate. But it can also be good because if you've got bad cells like cancer cells in you and you treat it with radiation, it can kill the bad cells. And therefore your bad cells cannot reproduce and make more bad cells. Any other questions? Yes?
Is there a way to target only specifically the bad cells, or do some of your good cells also get damaged in the process?
Oh, that is an excellent question. So, did you hear his question? He said, does radiation target just the bad cells? Well, radiation therapy targets just the bad cells, but it does hit some good ones. So let's say that you have cancer in your hip. The radiation would go right on the hip, and it will attack the cancer cells, but it will attack all the cells that are there, even the good ones, and therefore the good ones will also die. And so therefore you hope that you're able to kill the bad cells faster than you kill the good cells, because that could otherwise the therapy itself could kill you. And what happens is that sometimes people getting radiation or chemotherapy will lose their hair or will get very sick, and that is because the cells in the lining of your stomach and the cells in your hair are very fast growing, and the treatment affects the fast growing cells the most. Cancer is very fast growing, hair cells and stomach lining cells. So those are the ones that are affected the most, and that's why people lose their hair and get sick. But hopefully you kill the bad cells before you get too sick. Yes? I read my notebook all the time. It just depends on how much radiation you want to be exposed to. Yes, there are things that you can do to protect yourself. Alpha decay, alpha particles can't even go through paper. Beta particles can go through clothes, so you'd want to have better protection for those. And if it's stuff that's very, very radioactive, like the gamma rays, high energy, then you need to have much more protection, like lead and things like that. Are there any other questions? Yes? Yes, I have two daughters. My daughter, Marie Curie, went on and continued my research and won a Nobel Prize herself. And my other daughter ended up an author, and she wrote a lovely book about me. Any other questions? Okay, well, thank you very much for your attention. I'm going back to the laboratory because that is the most important place to be. And I'm looking forward to hearing from your teacher how you thought about it. Yes?
What age do you think you did that?
That is not an important point. The important point is how much am I going to learn before I die? Any other questions? Okay.